Good afternoon. I'm Ana Beatriz, and I'm going to present my master's project entitled KRAS-G12C, a neglected biomarker to detect individuals with MUTYH-associated polyposis. This syndrome, also known as MAP, represents 0.7% of all colorectal cancers, is recessive, is characterized by an attenuated polyposis, and has a variable phenotype, which makes it hard to diagnose. The MUTYH gene plays a role in the base excision repair system of the DNA, removing adenines that are wrongly paired with 8-oxoguanines. There is a type of base generated by oxidative damage. And when this gene is inactivated, the adenines will be paired with thymines, generating what we call G2T transversions in all over our genome, including in genes that are very important to the carcinogenesis of the colorectal cancer, such as KRAS. In the case of KRAS, these transversions are going to cause the G12C somatic mutation, which is extremely rare in other contexts, but is present in more than 80% of MAP patients. For these reasons, a few studies have proposed that every time that you identify this somatic mutation in colorectal cancer panels, you should refer this patient to the multi-germline testing because of the probability of this patient having MAP. 4 studies tested this hypothesis, getting the results of 10, 25, 6.7, and 11% of MAP cases in KRAS-G12C cohorts, which are very high values when compared to the 0.7 that are currently diagnosed. Besides KRAS, PIK3CA-Q546K has recently emerged as a new biomarker in this study of Georgeson from 2022 that follows the same rationale as KRAS, so being extremely rare in other contexts, but frequent in MAP. But here in this case, it was found in 37% of all the MAP adenocarcinomas. This study also demonstrated that the presence of these two somatic mutations identifies MAP patients with almost 90% of sensitivity, because both are associated with the SBS18 and SBS36 mutational signatures that I'm going to explain later. And for these reasons, these biomarkers should be used to reclassify VUS, or variants of uncertain significance, in the MUTYH gene. And how this could be done? So we could do this by applying the PP4 ACMG criterion, which predicts that tumor phenotypic features such as mutational signatures should be considered supporting evidence of pathogenicity. Regarding mutational signatures, they can be described as mutational patterns that occur in a person's life, caused by both endogenous and exogenous processes. And in the case of MAP, these two single base substitutions are very characteristic of the syndrome, with SBS18 being related to the reactive oxygen species damage, and SBS36 with a defective Bayer system and the MUTYH inactivation. And here in these two images, you can see that both of the mutational signatures are characterized by an enrichment of C2A exchanges. The general objective of my study was to evaluate the detection rate of germline pathogenic or likely pathogenic variants in MUTYH in patients with colorectal cancer and KRAS-G12C somatic mutation. This will be done by some specific objectives, and I'm going to start by these two that are the frequency evaluation of hotspot variants in MUTYH, followed by the complete sequencing of the gene in monoallelics. From a cohort of 220 KRAS-G12C patients, from which we collected some medical data and performed DNA extraction, they underwent the multiplex NGS of the 5 most common Brazilian variants in our population. When the patients were homozygous or heterozygous with 2 of the evaluated variants, we evaluated the possibility to perform allele-specific PCR to confirm or infer MAP. For heterozygous cases with 1 of the evaluated variants, we performed the multi-complete sequencing, and when a second GPV was not found, we classified this patient as monoallelic. And for negative cases, we just presumed that they are not MAP. From all of the patients that underwent the multiplex sequencing, 25 had at least one GPV in multi, and 15, or 6.8%, were identified as MAP. Of these 15, 8 were confirmed and seven were inferred. The age ranged from 27 to 75 years old, the polyps from 1 to multiple, and the family history of CRC was variable. Here in this chart, you can see the frequency of the multiplex variants assessed, with Y151C being the most frequent, with 40% of the cases. The third objective is the clinical and anatomopathological correlations with the GPVs found. After their detection by specific softwares, we performed some statistical analysis to identify potential correlations. From all of the variables assessed, we only found a statistical significant difference in median age and polyps, showing that patients with GPVs in the multigene have a lower median age of CRC onset and a more prevalent presence of polyps when compared to patients without GPVs in the gene. The fourth objective is the utility of investigate PIK3CA, Q546K, and KRAS-G12C, and the mutational signatures SBS 18 and 36 for VUS reclassification. This objective is basically composed by 3 groups. The group 1 and 2 are the control groups, which included multi-negatives from tertiary data and 16 diagnosed MAP patients from our hospital, in which we showed the frequency of these 3 biomarkers. And the group 3 that is composed by the patients with VUS in the multigene. In these patients, we tried to detect at least one of these 3 biomarkers, and when one of them was detected, we revised the ACMG criteria and the clinical data of the patient and compared with the frequency found in controls to analyze if we had support for reclassification. Regarding the signature analysis, after the whole exome sequencing of CRC and adenoma samples, followed by the somatic variant calling by the GATK pipeline, we performed the signature analysis using the SIG Profiler suite of tools. From the 16 MAP patients, we found that 12 were mutated for KRAS and 5 for PIK3CA. In adenomas, almost half of the samples were mutated for KRAS and none for PIK3CA. But in adenocarcinomas, almost all of the samples were mutated for KRAS, and 5, or 38.4%, were mutated for PIK3CA, which is a value very similar from the one that Georgeson observed in his study of 37%. In the negative control obtained from the literature data, we found that 2.4% were mutated for KRAS and 0.7% were mutated for PIK3CA, showing the high contrast between these 2 groups. Until the moment for the mutational signatures in positive controls, we evaluated 8 low-grade adenomas and 1 adenocarcinoma. Here in this table, you can see highlighted in red the SBS 18 and highlighted in blue the SBS 36. And here, from all of the adenomas that were assessed, we found that all of them had at least one MAP-related signature, varying from a frequency of 21.8% to 93.8%. Here's an example of the reconstruction provided by the SIG profiler. On the top is the original sample before the reconstruction, and below is the sample after the reconstruction provided by the software. And here are all the mutational signatures that were identified by the program, with SBS 36 having a very high frequency of contribution of 93.75%. About the VUS reclassification, we only had support for reclassify the VUS of the second patient because his adenocarcinoma showed both of the somatic mutations in KRAS and PIK3CA. For this reason, we could apply the PP4 supporting criterion together with PM2 supporting and PP3 strong, having the support to reclassify his VUS to likely pathogenic. Concluding, 25 KRAS-G12C patients harbor at least one GPV in multi. Of these, 15, or 6.8%, were classified as MAP, And when adjusted by age, in patients under 60 years old, this rate increased to 11.8%. The high detection rate of this biomarker, therefore, suggests its use to identify MAP patients. KRAS-G12C and PIK3CA-Q546K are suitable biomarkers for VUS reclassification in adenocarcinomas, but not in adenomas, and all adenomas showed at least one MAP-related signature in a frequency greater than 21%. So even though adenomas are not a good sample to identify the somatic mutations, it may be a good sample to detect the mutational signatures. I would like to acknowledge to all the collaborators of my study from Maci Camargo, Hospital de Amor de Barretos, Hospital Erasto Gartner, the financial support, and to the ISCB organization for the invitation to present my project. Thank you very much.
Have you searching the big or large data sets that have mutation in colon cancer of your mutation?
Could you please repeat more loud?
If you have, you've been investigating some specific mutations. Mutations. Have you checked out in the tumor databases of colon cancer where there are mutated profiles if your mutation is present?
I don't know if I understood, but for KRAS, they are present in more than 80% of the tumors and 90%. There's a lot of studies since 2000 that has this information, but PIK3CA is very recently was identified first in this study of Georgetown of 2022, and this is the only data that we have regarding PIK3CA. The other ones, like for this specific mutation, I haven't found. There's a recently study actually that was, I think, from a year ago that also showed, and the frequency was around 30%.